Hi everyone, welcome to yet another video in this series Python for Beginners, and in this video we are going to be looking at objects in Python. Now in the last video we were able to look at how to install Python. We look at some things concerning the Python interpreter, and then we were able to look at some basic syntax in a Python program. Now in this video is going to be objects in Python, and let me categorically state that this video isn't about object-oriented programming, and this video is not also going to look at how objects are organized at the low level in Python in memory. But this video is designed to get you started as a beginner in Python, to get you to understand what objects are in Python. So what are actually objects in Python? Now let's just say everything you see in a Python program is an object. Like for instance, let's look at this simple Python program I've written. Anything you see here in this Python program is actually an object. Like for instance, this card is an object. This equal to sign is an object. This ANS, this double equal to this yes, and everything you see here is an object. Now if everything in a Python program is actually an object, then how do we make sense of this program? For me is by finding a way of categorizing each of these objects into a specific category or class, and this leads us to what is known as object types. Python object types or classes in Python. Now there are two broad ways of categorizing object types in Python. There are the built-in types, and there's what we call user-defined types. Now we are not going to discuss user-defined types in this video, as we are going to be discussing that in a separate series. But what we'll be looking at is built-in types. Now what are built-in types? Now built-in types of objects are the types of object that ships in with Python. Immediately you install the Python interpreter, then those types of objects are available for you to use in your programs in Python. Now what are there are so many of them, and we are going to look at some of the primitive types, some of the core types of objects that we can find in Python. Now the first among them we are going to look at is int. Now int stands for integer. Now if you are writing program logics that deals a lot with whole numbers that are 1, 2, 3, 4, 5, or maybe minus 1, minus 2, minus 3, if at all it is whole number, then you want to use an integer in those areas of your program. In programs like in compilers like C#, you are going to find out that even the integer is further subdivided into like something like a signed and unsigned integer. But we are going to look at that in Python because Python is dynamically typed. We are going to look at how these are being created in Python. So integer is one of the types of objects you are going to find in Python. And then another type of object is the float. That's floating point numbers, and these are numbers that deals with decimals, like for instance 3.24, or it depends on the precision you want. That's how you are going to write the program. But one of the numeric types is a float. Like for instance, if you are dealing with programs that deals with currency, you may most likely going to use a floating type object in that logic. Now there is also Boolean. We call it bool in Python. It's being represented Boolean logic. Now the Boolean data types deals with two values mainly, true or false. Now if you want to evaluate a logic and you want the result to be either true or false, then you most likely use a Boolean object in that area of your program. Like for instance, if you want to write a program that a user will enter in a password and it will check against the database to see whether the password is in the database in order to grant the users access to some resources, then you most likely use a Boolean logic. Anything that use conditional statement is actually being evaluated as a Boolean. If a certain condition is met, then do so and so, else do so and so. Then that is Boolean logic. And then there is also string data types, str. We call it is string data type. So you are most likely going to use a string data type in program that has to do with sequences of characters. Like for instance, that has to do with a lot of letters, something like Microsoft Word or any other program or any other area of your program that deals with sequences of characters. You most likely use a string in that area. Then we also have another type of object in Python known as the list. Now, list is a bit different from them because list is more like a container that holds different objects within it. Like for instance, you can put in a number like integer, you can put in a floating point, and then you can put in sequence of characters, or even user defined types. When we discuss them, you can put a sequence of user defined types within a list. So list is more like a container that holds different kinds of objects within it. And there's also another sequence type of program known as the tuple, T-U-P-L-E. Now a tuple is also like a list, but those values are held within a parenthesis separated by a comma. Like for instance, you put one value here and then you put another value here. So it's also like a list, but it has a slightly different use, can be used slightly differently in a Python program. Then we also have a dict, which stands for a dictionary. Now it's more like a value map. When I say a value map, what do I mean? Like you enclose it, you put your objects within double curly braces, and then you map. Like for instance, let's say name. If you want to model a person, name, and then you put in the name, and then you put comma, then maybe age, and then you put in this colon, and then put, and then it goes on and on and on. Now this is what a dictionary looks like. A value map, it comes in pairs with key and then a value. We are going to look at this in much more detail. And then we also have a set. Set is also like a dictionary enclosed within a curly brace, within curly braces, but you don't create map. You don't map values in a set. You create a sequence of values, but now this sequence of values cannot be repeated. Like for instance, if you put a 1, 2, 3, 4, 5, and then you put another one again, now a set is going to ignore this one and then use this one. Now that is what a set is. And then how do we go about creating them in a program? Like, okay, now we do that by means of what is known as instantiation. Now we instantiate an object. How do we go about doing that? Like for instance, each of this type of object, there's a way we instantiate it. Like we put the object name, like for integer is called int. You don't write complete like integer in Python. You don't write it this way. You write int, and then you put a parenthesis. Then you pass in the value of the object that you want, like for instance 54. Now it's going to construct this object of 54 and then return it. Like for instance in float, you can write float and then you pass in like 3.45, and then maybe in a boolean value you write bool and then put an opening and closing parenthesis, and then you put like true or false. You put true or false depending on the value. Now this is going to return the value that you pass in inside of this object types, and then you need to capture it and store it somewhere, and that is where identifiers come in. Now what are identifiers? Identifier is any name you choose at all, but it has rules though. But any name you choose to give it as a description to the kind of object you create. Like for instance, let's say this is G, then you put an equal to sign, though we call it an assignment operator, so we are going to discuss operators in a different video. Let me remove this. Then it's going to construct 54 from this int and then store it inside of this identifier known as G. Now let's print it to the console and see. We are going to look at the print function, don't worry about it. Like for instance, if you execute this, G is going to give you 54. Now let's go back to identifiers. Now we said identifier is any name you choose at all, anything that you choose that describes the value you want to construct. But there are rules to that. Like for instance, an identifier cannot begin with a number. Like for instance, if you put like 1G and then you try to print 1G, is going to give you a very ugly error. Look at it. It's going to give you a very ugly error in this place, invalid syntax, as you can see. So an identifier cannot begin with a number, but it could, if it begins with a letter, there could be a number in it. Like for instance, G1, if you put, let's put G1 and try printing it. Let's see, G1, and then printing it, and it's going to give you 54. Like for instance, 54. Now, Python is case sensitive. When I say case sensitive, I simply mean, like for instance, this lowercase g1 is not the same thing as this g1. They are two different things. So if you put this g1 and then put int, let's say int 3 in it, and then you print g1, and then you print another uppercase g1, is going to give you two different numbers. So this is not the same thing as this, but by the time you put lowercase g1, now this one is going to overwrite this g1. Okay, let me remove this since it's not there. That's why it's giving us this error. So as you can see, it's now 3. It's not the same thing as it's not the one for the initial 54. So Python is case sensitive. So uppercase g1 is not the same thing as lowercase g1. You can also begin an identifier with an underscore. Like for instance, if you write an underscore 1, let's see, then you write underscore 1, which is equal to, let's say, int 55. Now if you print this one, you're not going to have any problem with it because it begins with an underscore, not a number. So let's print it. Look at it, 55. So it must never start with a number. That's the number one rule. And then it can start with an underscore, and then you give it a descriptive name, something that describes the value you are trying to create. Now, usually that is not exactly what you do if you are creating if you are creating an integer type, then you must write this int before this 54 passing the value. Usually people don't do anything like that. Let's say we want to create a variable known as age, then we want to create something that captures the age of people. Then there's what we call literal types. Okay, literal objects, literal forms, literal forms of objects. Now, instead of writing, if you are writing, like for instance, you are capturing age, instead of writing int 54, then you only write 54. Now, this 54 is going to be created and then be captured in this age. Now, Python automatically knows that this 54 is actually an integer type, so it's dynamically typed. That is what we call dynamically typed program. Python is dynamically typed. Like for instance, if you put 54.3, Python is going to know automatically that this is a float type. Like for instance, let's print it and see. Print type, and then we put age, and let's see what Python is going to class. Look at it, float. But if we are going to remove this and then print it, then look at the class is an int. Then if we are going to put another literal type, like for instance bool, this boolean literal type, we are going to put like directly true. If we are going to print it, it's going to give us, look at it, bool. And then let's look at string. Now, how you create a string literal type is by putting either double quotes or single quotes, and then you write something inside of it. By the time you print it, look at it, it prints str. And now, even if you put numbers in here, by the time you put it under, in between a double quote or a single quote, is going to see it as a string data type. So unless, like for instance, if you are writing like 54 and is giving you integer, and then you wanted to convert it into float, then you write float and then you open and then you put 54. Now look at it, it's going to give you float. And if you print age only without writing the type, trying to see the type, is going to give you 54.0. So it has automatically converted it. Now, if you are writing a program that you are not very sure exactly the value that the user is going to enter, but what you want it to be is a float type, then you use this convention. But otherwise, using the literal form is very, very much okay. Now, going back to identifiers. Now, you don't just name identifier. Apart from these rules that we have given you that you cannot begin with a number, so and so, you can't actually name it anything you want. There is what we call reserved words that you cannot use words that you cannot use in Python to create an identifier. Like for instance, there are 33 of them. Number one is false. Now you cannot use the word false and create an identifier. Like for instance, let's use it false with an uppercase F. If we use this word false trying to create an identifier, it's going to give us an error. Look at it. So cannot assign to false. So false is one of those reserved words that cannot be used to create an identifier. Now I'm going to pause this video and then type all of the words to you so that you'll be able to see them. Now these are the list of reserved words that you cannot use to create an identifier. This is a false with an uppercase F, as, continue, else, from, in, not, return, yield, none with an uppercase N, assert, def, except, and global, etc. Now these are a list of 33 words that you cannot use to create an identifier in Python.